Hi, I'm Dr. Yo, aka Aaron F. Ross. Delighted to bring you the third installment of Video Synth Tools and Techniques. I'm here to share what I've learned about video synthesis and the LZX modular ecosystem. This episode is all about the LZX Swatch module. And wow, my friends, just wow. Swatch opens up a whole new area of creative potential. It is a portal into another dimension. Welcome to Planet Chroma, where we can do amazing things with color that simply aren't possible in an RGB patch. If you haven't already seen the official Swatch video by Johnny Woods, I strongly recommend you take a look at that also. The headline of this story is that Swatch can separate luminance from chrominance. That is a huge deal. Luminance, or Luma, is brightness, and chrominance, or chroma, is color. It is not possible to separate them in RGB land. Changing the RGB primary colors always affects both Luma and chroma. But Swatch empowers us to manipulate Luma and chroma separately, imparting all sorts of new abilities. The immediate killer application of Swatch is to process luminance. On the most basic level, Swatch extracts the Luma or Y signal from RGB video. There are other ways to do that. VUO3B and TBC2 decoders, for example, have luminance outputs. The Proc module can convert RGB to luminance, as I showed in my first video. Foxing Hour has a dedicated module called Luma that does it more precisely. But Swatch is the all-purpose Swiss Army knife to convert RGB to luminance, or vice versa. One thing that makes Swatch unique is it has a luminance input as well. We can patch Luma out to another module and return it back to Swatch, which then transcodes back to RGB. This is a breakthrough, my friends. Suddenly, every existing monochrome processor module effectively works in color. All single-channel processors now have a new lease on life. You can send the Luma out of Swatch through stairs, DSG3, VU005, etc., and back into Swatch. You'll be glad you did. As for the chroma, you can choose to leave it alone, keeping the color of the original RGB source, or process the chroma separately, replace or combine it with something else. This is a whole new way of working that retrofits all existing modules and opens the door to creative possibilities that we could only dream of in an RGB patch. Another superpower Swatch gives us is control over saturation or intensity of color. We can remove saturation completely by simply using the luminance output. Or by patching Swatch to itself, we can double the saturation. If you want to art direct the level of saturation and dial in a specific level, you'll need to send Swatch out to some other module and then back into Swatch. The ideal module to pair with Swatch is Proc. Also, the Video Headroom System's Crossfade module comes in very handy because with that, you can adjust saturation with a single knob, and you can also modulate saturation with a control voltage. This brings us to a technical consideration when manipulating color with Swatch. The color components, called I and Q, are bipolar signals. The voltages need to go both positive and negative in order to represent all possible colors. To process I and Q without losing half of the information, and therefore mangling the color, a module must be able to handle a bipolar signal. The modules that I know can definitely do this are Proc, Passage, Foxing Hour Access, SMX3, Crossfade, the fader submodule of Bridge, and the triple function generator. But most LZX compatible modules won't pass a bipolar signal. The negative voltages will simply be discarded. So for the full Swatch experience, To process I and Q through any module, you will also need two modules capable of biasing a signal, such as Proc. Once you've got the polarity thing handled, you can do great stuff by combining I and Q with other signals. The simplest operation is just adding control voltages to I and Q, which will shift the colors around. And of course, varying or automating the control voltages will animate those color shifts. One of the annoying things about RGB is how hard it can sometimes be to dial in a specific color. And that's because, again, adjusting any of the three primaries will affect both the luminance and the chroma. You can't just brighten everything all at once, for example. But YIQ makes things a whole lot easier. The mere fact that you can adjust luminance separately from chroma is going to cut your grief factor in half. So far, these have all been fairly straightforward applications of Swatch. But of course, in video synthesis, we want to go crazy and do stuff that might make a video engineer's hair stand on end. What kind of insane stuff can we do? Well, with Proc and SMX3, we can completely mess with the YIQ signal, just as we could with RGB. SMX3 is perfect for colorizing in any component space due to its internally normaled connections. We can convert any of the YIQ components to another, and with a matrix mixer like SMX3, it's super easy to cross-contaminate those channels, combining them in weird and wonderful ways. This is a freakish new form of colorization I've never seen before, and it will blow your funky mind. Before we get started with the hands-on demo with the synth, I want to provide some conceptual framework on the YIQ color space. Here's the reticle, or measurement overlay of a vector scope. This should be familiar to you. Looking at the vector scope, we see a pair of horizontal and vertical crosshairs. The lines pointing east-west and north-south are the U and V axes, respectively. These are the reference axes for the UV color space. U and V are the generic names for the color difference channels that you're probably familiar with from analog component video. The U color component is also known as PB, or in the digital world, CB. It is the color difference channel of blue minus Y. The V color component is also known as PR or CR, and it's the color difference channel of red minus Y. You'll see another pair of crosshairs, this one tilted to the left. These are the I and Q axes. They define more or less the same color space as U and V. Here are the colors of the IQ space at a luminance of 50%. Now, not all of the colors in the IQ or UV spaces can actually be reproduced by the RGB color primaries. Anything outside of the circle is illegal, meaning it cannot be recorded or broadcast. And in fact, the practical limits are even more severe than that. The usable RGB space is only a roughly hexagonal region in the center. Both systems cover the same legal color range within the vector scope circle, except the IQ coordinate system is tilted 33 degrees. Why is IQ tilted? It's because the positive I axis is aligned with human skin tones to make the broadcast signal more robust. Skin tones are important. We're prioritizing them so they're less likely to get mangled by interference. And by the way, the orientation of the I-axis is not racially biased. Skin tone comes from the amount of melanin in our skin, which has the same hue for everyone. Let's begin by just taking a look at the swatch panel and seeing how the signal flow works with swatch. It basically operates in a clockwise direction starting from the lower left. Anything you plug into the RGB inputs is going to flow to these Y, I, and Q outputs. And then some of those are internally normaled to the Y, I, and Q inputs here. Anything that is plugged into Y, I, and Q, either through the normaling or through a patch cable, is going to get transcoded back to RGB. And those RGB outputs are here. We have two sets. We have clamp and over. Clamp just makes sure that whatever appears at these outputs conforms to the 0 to 1 range of the LZX modular standard. The over outputs are raw outputs. Remember that I and Q can exceed the RGB gamut, or the range of possible colors. So you might need these over outputs if you've got extremely hot YIQ inputs. You could take those over outputs and then attenuate them manually, maybe with Proc, to make sure that you're not losing any detail. Okay, so that's the general signal flow. Let's plug something in. I've got a decoder here ready to go. It's the Synth VU03B. I'm going to plug that into the RGB inputs of Proc. And with those clamp outputs plugged into my encoder, we see a color image. At this point, Swatch is doing nothing. And it is doing nothing exceptionally well. Almost any other module is going to affect your signal in some way. And you'll especially see this with high definition signals. Any module is going to introduce some latency, which is delay. That'll manifest as a horizontal shift. And any module is probably going to also introduce some blur to your image horizontally, because really these modules are just barely fast enough to handle high definition video. But Swatch is in a class by itself. It is almost perfect. It's going to really just do nothing to your signal. It's going to pass it through completely transparently. And if I plug my decoder directly into my encoder, I would not see any difference versus going through Swatch, which is great. So we can really rely on Swatch to really do nothing to our signal that we don't want it to. Cool. All right, so let's talk about internally patching Swatch. Now, Johnny Woods covered this in his video. We could take any of these outputs and plug them to any of the inputs and just do, crazy experimental stuff. The most obvious thing is to double the saturation. We can take the negative I output, plug it into the negative I input, and likewise the negative Q output to the negative Q input. And we just doubled the saturation. And that's because these inputs are going to add to the other inputs. And, it's kind of actually giving a result you wouldn't expect. You would have thought maybe that we would get an inverted I adding to a positive I, causing them to cancel out. But that's not what's happening, because we're taking this inverted I and then inverting it again by plugging it into this inverted input. Okay, so we're actually adding I to I. We're not subtracting. Okay, so that took me a little bit of thinking to wrap my head around, but it works and it does a great job. Okay, of just doubling the saturation. But of course, we can do all sorts of other insane stuff here. We can cross patch these in crazy ways, in ways that don't necessarily make logical sense, and get some weird color effect, and that's pretty neat. Do keep in mind, though, that all the I and Q signals are bipolar, so if you do things like try to connect luminance to chrominance, you might not get the result that you want, right? If I take the Y output and plug it into, for example, the positive I input, we're not getting all the possible colors that I can reproduce. We're only getting half, because we're taking a unipolar signal from 0 to 1 and plugging it into an input that expects a bipolar signal from negative 0.5 to positive 0.5. Now, we are going to do some crazy stuff with converting the luminance and chrominance back and forth, but to do that, we're going to need to use a different module. We can't do it directly from the Swatch panel. anything that we plug into these Y, I, and Q inputs is going to override whatever's normaled into them, right? So at this point, nothing's plugged in there, so we're just passing our original color signal through. But now let's go into sort of the guts of how Y, I, and Q work by using Proc as a color picker. All right, I'm going to take my cables and take the output of Proc channel 1, go into Swatch Y input, Proc channel 2 into Swatch I positive, positive I, and Proc channel 3 into positive Q. And now we've got a color picker set up. We can increase the luminance. Okay, very cool. Maybe set that at 50%. And then we've got the chrominance. We've got two color channels here. Positive I is going to push our color towards orange. If we invert it and give it a negative value, we're going to push towards cyan-ish. And then we've got Q. Making Q positive is going to go towards purple or magenta. Pushing Q negative is going to go towards green. But these are not really linear or logical. They don't move in straight lines. Look on the vector scope and we can see that dot moving around. That indicates our current color. And I would expect that all else being equal, if I move Q up and down, then that would move along the axis of Q, but it's going off axis and doing stuff we don't expect. All right, so that's just kind of something we have to live with. It doesn't make a lot of logical sense, but it's okay because we can still dial in any color we want by adjusting these three knobs, Y, I, and Q. And again, it's very important that we use a bipolar voltage source to do this. Otherwise, we'll only be able to access half of the possible hues. So really, Proc is the ideal module for this. We wouldn't want to use the matte module to drive I and Q because matte is unipolar. Awesome. All right, so again, any color you like. All right, let's talk about processing. The most basic thing you'll want to do with Swatch is use the color in an existing image, but manipulate the brightness in some crazy way. So I'm going to disconnect these I and Q for now. So now whatever's coming into my RGB inputs is going to affect the I and Q of my final output. And if I adjust the luminance here, we can see that we're getting this kind of strange effect here where there's no detail. We've just got color only. What we really want to do here is take the Y output of Swatch and patch it through something. So I'll just use Proc. That's really the most obvious thing to do. Okay, so with the bias set to 0, then we've got a gain knob for the brightness that does not affect the color in any way. One of the things I've wanted to do forever with video synthesis is invert the luminance but leave the chroma alone. And with this very simple patch, we can do that. We can just bring our luminance down into the negative zone with our attenuverter and then bias it back up into the positive zone. There it is. We've just inverted the luminance but left the chroma alone. Or likewise, we could send the luminance through anything, really. In the Johnny Woods demo video, he used stairs, but really anything is going to work here. So I've got my DSG3 here. Maybe we'll do that. I'll take the Y output, plug it into one of the channels of DSG3, and then break the normal to the other input using a dummy plug, and take the output of the dual shape generator. We'll take the absolute output and play around with all these switches here, right? We've got negative, we've got folding, and we've got exponential and logarithmic. All kinds of crazy stuff. Look at that. How awesome is this? And we've kept the original color, but totally mangled and weirded out the luminance. I love this. All right, so there it is. All of your existing monochrome modules now have color. And of course, we could plug something else into these other color inputs, but I'll leave that as an exercise for the viewer. Moving on, let's talk about sending Y into Proc and using it as a way to tint an image. All right, so I'm going to take this Y output, plug that back into the B1 input of Proc, and take the channel 1 output of Proc, just restore these back to neutral. Okay, and additionally, I'm going to take the channel 2 output of Proc, plug that into the positive I input of Swatch. Take the channel 3 output of Proc, that's going to go into the positive Q input of Swatch. And now I'm going to tint using this Y signal. Because of course, Proc is internally normaled. Anything we plug into this top B1 input is going to flow into B2 and B3. So now we can send the luminance to the chrominance. So I can increase the gain of the Q channel, and I can play around with the bias as well, so we can get kind of bichromatic look there. Cool. We can do the same here with the Q channel. We can send that gain into positive and its bias into negative and just see what that does. Or of course we can invert that and then bias it up, get the reverse. Very cool. So we can now use luminance alone to colorize an image, kind of the same way we could do in an RGB workflow, except we're going to get a different look because we have different parameters. Great. All right, we can take this up to the next level by patching all 3 color components through Proc. I'll start just by resetting my I and Q to neutral or monochrome, just so we'll have a sort of baseline to start from. Setting that so that my vector scope dot lands right in the center of those axes. Then I'll take the positive I output of Swatch, put that into the B2 input of Proc, and take the positive Q output, go into the B3 input of Proc, and then simply increase the gain of B2 and B3, and we get more or less the same image that we would get if we didn't go through Proc. Proc is going to soften up the image just a little bit, but it's not going to do too much damage. But now we have total creative freedom with Y, I, and Q. We can attenuate any of them. So of course we can start by inverting the luminance, but we can also play around with chroma too. So I'll bring luminance back down to normal and maybe invert the I signal and then bias it to compensate. Or I can invert Q, bias that as well, or do any combination thereof. And with this patch, we're tinting similarly to what we did before, except now we're going to preserve more of the original color information because we're working with I and Q, mapping them onto themselves after having been mutated a bit. So this is going to give us more range of color than simply tinting using the Y channel as the source. Now, as we can see, we can adjust the saturation here, right? If we neutralize these bias controls, bring those into neutral, then we can actually dial in a certain amount of saturation. Let's examine this a little bit more deeply. I'm going to disconnect my luminance. So we're not actually going to be dealing with that right now. We're just only dealing with chroma. So in this patch, really I'm just able to dial the saturation down to nothing. But what if I wanted to increase the saturation? I could patch negative I to negative I and negative Q to negative Q here. That would double the saturation, but What if I want to control the saturation between a range of 0 to 2 times? Well, I could actually send my I and Q through SMX3 because these attenuverters also have amplifiers. So I could crank I and Q up if I went through SMX3. But I don't really want to do that because SMX3 is likely going to introduce some DC offset into the signal. Even if nothing's connected, the outputs of SMX3 are not necessarily going to be at 0. That's kind of unfortunate, but that's been my experience. And we could fix that by putting some value into one of the inputs here. We could send a positive or negative voltage in order to compensate for that DC offset. But in order to do that, we're going to need to use Proc anyway. So the streamlined method here for adjusting saturation via Proc is to send the I and Q signals into more than one of the Proc inputs. If we just double up positive I and put that into both the A and B inputs here of channel 2 and double up positive Q into the channel 3 inputs, we're going to get the result that we wanted. And we can do that with a passive mult. We don't need to use an active mult because our cable lengths are going to be super short here. And I'm just going to use these wonderful tip-top audio stack cables. All right, let's do it. So I'm going to take one of these stack cables and connect the two inputs here. That's going to be A2 and B2. Likewise, we want to connect A3 to B3. And then connect our I and Q respectively. I is going to go into the channel 2 input, and Q is going to go into the channel 3 input. All right, and with the gain knobs and the bias knobs set to neutral, we're not doing anything here. We're just taking whatever goes into the A inputs here and sending them to the outputs. But if we do increase these gain knobs, then we're going to actually be adding A and B. And now we've got double saturation. And to make this even more fun, we can invert these, bring those down into negative, and we've subtracted the saturation through phase cancellation. We've added the inverse. Positive I is coming into the A input. Positive I is also coming into the B input, but the B input is inverted. And by the way, you probably will need to look at the vector scope and dial this in exactly to make sure that you're not getting any unexpected results. You might need to play around with the bias controls and so on. But bottom line is we can basically go from 0 saturation to double saturation just by using Proc alone. Well, it is a little bit inconvenient to work with two knobs. It would be better if we could do this with just a single knob, and that's where Crossfade comes in. So I've got the brown shoes only version of Crossfade, but this should work just fine with the newer Video Headrooms systems version. Okay, so instead of sending Proc directly back into Swatch, I'm going to send it through the Crossfade module. I'll take the I output of Proc, that's channel 2, put it into, let's say, the G2 input of Crossfade, and we'll take the third output of Proc, channel 3, put that into the B2 input of Crossfade, and likewise we're going to take the outputs of Crossfade. We've got the green or G output, that's going to go into the Swatch positive I input. And then we've got the blue or B or third output of Crossfade. Plug it into positive Q of Swatch. If this Crossfade knob is all the way to the right, we're just taking whatever is at this second input. If we dial that down, we're subtracting. And by the way, we probably want to set this control voltage to neutral as well, so we're not actually adding any bias there. Okay, so with the fade knob set to the left, we're sending the first input of crossfade to the swatch I and Q, and nothing is connected to those inputs, so we're sending nothing into I and Q. But if we increase this knob all the way up to the maximum, we've got double saturation. All right, so that's how we can art direct saturation. If we're at the midpoint here, we're going to get approximately, neutral color, right? We're not really increasing or decreasing. Crank that up and we've got double saturation. Awesome. So that's another thing that I've wanted to do forever with video synths, is just have that control over saturation. Set it to what I want it to be without having to mess around with, 3 different RGB knobs, which is crazy talk. Okay, so we can take this even further by sending something else into the crossfade inputs. And I've got another Proc module I can use for that. So I've got another one. It's kind of off screen, but I'm going to take the negative I, send that into Proc, and the negative Q, send that into another Proc as well, and then return those back into crossfade. So now I've inverted the color. So in the center position, those two colors are actually canceling one another out. Those two procs are now kind of, canceling. So I've got double saturation. I've got, normal saturation, no saturation, slightly, desaturated inverted color, and fully saturated inverted color, and anything in between. That's pretty great. And since crossfade has a control voltage input, and since that control voltage input is a video rate input, I can plug anything into that. So I've actually got a plan here. I can take, for example, my oscillator. I've got a DW03 oscillator. I can take its square wave output, plug that into the control voltage input just to show you what we can do. And we can play around with these different knob settings and see, what kind of results we can get. So here we've got alternating bands of positive and negative color. Pretty cool. And of course, I could do crazy stuff with my oscillator. I could frequency modulate that oscillator with another oscillator, and do the usual kind of crazy video synth stuff. That is using crossfade as an IQ modulator. Pretty great. Now we're ready to start combining I and Q with other signals. And the perfect tool for that is the SMX3 Matrix Mixer. As I previously mentioned, you may encounter an issue with the SMX3 where it is introducing a DC offset or a bias to whatever signals, and we can actually see that on the scope. Let's see what happens. If I just take the outputs of SMX3, I'm taking the channel 3 output, putting that into positive Q of swatch, taking the number 2 channel output of SMX3 and putting that into the I positive input of swatch. And if we look at the scope already, we can see that our little dot's not quite centered. And if we start playing around with these knobs, we will see that dot move around. That is the DC offset or bias that's actually sort of inherent in the SMX3. We're going to have to compensate for that. And the way to do that is to send a bias into one of the channels. I'll do that with Proc. I'll take the channel 2 output of Proc, put that into the C2 input of SMX3. Take the 3 output of Proc, put that into the C3 input of SMX3. And I want to increase the gain of C2 and C3, not a lot, just a little bit. I'm going to set that to maybe like, I don't know, 2 o'clock, because I want to be able to have the maximum range of the knobs on Proc. And since these guys over here are actually amplifying things, I don't really want to do that. This is very delicate, so I want to try to get this right. So as I adjust these Proc knobs, the bias knobs on Proc, I can actually dial in, once again, a neutral monochrome, image with no color in it. So that's my baseline. Now I'm going to start adding things. I'm going to take the positive I output of Swatch and put that into the A2 input of SMX3. And the positive Q output of Swatch, put that into the A3 input of SMX3. And then bring those up. If I set those to about the 3 o'clock position, then we should be getting more or less unity gain. But we can see that it's not. We're getting a weird tinting here. So this is where we need to start, working with these Proc knobs and biasing that signal around in different directions. And really, we're just doing this kind of by the seat of our pants, just visually trying to match what we think the image should look like. And that looks pretty good there. Okay, so now we're sending our original color through SMX3 and passing it more or less transparently. And we're ready to add something to it because we've still got another set of inputs available here. So those are the B inputs. And I'm going to take the outputs of my VU006 quadrature sine oscillator from Synth. And I've got the 0 phase output. I'm going to put that into the B2 input of SMX3. And I've got the 90-degree phase output of my quadrature oscillator. Put that into the B3 input of SMX3. And then I can increase the gain of those two. And boom, we're starting to see some animation. And it's moving around kind of in a circle. But it's not really a full circle. It's not centered on our vector scope. But that's where these bias controls come in. So I want to bias this whole thing down in both I and Q in order to compensate for the fact that I'm adding the original color to this sine wave. And additionally, that sine wave is unipolar. It's from 0 to 1. It doesn't have any negative component. So that means I need to bias this down even more than I might otherwise. But really, this becomes kind of just sort of a process of playing and dialing this in to get what you think you want. And maybe I don't want as much amplitude on those sine waves. And if you turn the frequency of your oscillator up enough, then you can kind of get a better sense. I mean, that might not be the effect that you want, but that's going to help you in terms of, seeing all those colors happen on the screen more or less at the same time. And then you can more effectively dial in the bias that you want for that particular oscillator. Okay, and then I can bring my frequency back down again. So now I'm animating the color in a circle. And if I change up the outputs of my VU06, I can make that go in a different direction. So instead of taking the 90-degree phase, I can take the 270-degree phase. And that's now feeding into the B3 input of SMX3, which corresponds to our positive Q. Now that means we're going the opposite direction using the 270-degree phase instead of 90. Or I can switch it back to 90. And now we're moving in a clockwise direction once again. Awesome! How cool is that, right? So that's just one application here. I've also experimented with using random voltages in here. You can see some of those in some of my Facebook posts. So we can, make that color sort of pop around on the color wheel in different locations. That's a much more advanced patch. I really don't have time or energy to go through all of that here. But, the sky's the limit here. You can plug in whatever you want and, animate that in any way you want. And of course, this is just dealing with I and Q. I'm not even modulating luminance, but just with this modulation of only the color components, we can see we're getting a really cool effect. All right, that is how to add signals to I and Q and offset them and animate them. Okay, to wrap up this marathon video session, I want to show you how to use SMX3 to convert any of the Y, I, and Q to one another and also manipulate them and invert them, cross-contaminate them, and just completely go hog wild and insane. So we're going to do this by patching the swatch outputs into SMX3, taking the SMX3 outputs and sending them into Proc because we're going to need to bias things around, and we need actually 4 channels of mixing to do that. We need 1 channel for each one of the components, and we also need another channel for the bias itself. So I'm going to just restore all these to more or less neutral settings, and I'm going to take my handy trusty LZX mini snakes because I've run out of white cables. I'm going to take the Proc output and plug that into the swatch YIQ inputs. Okay, so Proc is going to come later in the chain here than SMX3. Now the matrix mixer outputs are going to need to go into Proc. So I'm going to take each one of these red, green, and blue 1, 2, and 3 channels and plug those into the B inputs of Proc in case I decide I want to invert or attenuate, because those A inputs are just going to pass through. And then finally, I want to take the YIQ outputs of swatch and plug those into the top row of inputs on SMX3, the red ones. So those are all of the channel 1 inputs. And of course, like all the Gen 3 modules, these inputs are internally self-normaled, so anything we plug into this top row is going to flow into the other 2 channels. And that is our patch. We're sending swatch into SMX3, SMX3 into Proc, and then back into swatch. Okay, so here we go. First thing we need to do is make sure all of our Proc gain knobs are up at their maximum. And looking at the scope, we're going to make sure that we haven't introduced any bias to begin with. Setting all those bias knobs so that our scope reads really nothing, right? So the way to do that is actually to increase the luminance and then tweak the I and Q. All right, so now that's pretty much where we want it to be. And we can start going crazy with SMX3. So the first column here is going to correspond to our Y inputs. The second column is the I inputs. The third column is the Q inputs. So if we increase A1, we're just sending luminance to luminance. And if we set that to the 3 o'clock position, we're getting more or less unity gain. If we increase B2, we are sending the I signal into I. And if we increase C3, we're sending Q into Q. And it's not exactly the right color, based upon, the image that I created, but it's close. And if we mucked around with these bias controls, we could actually get it to land where we want. Okay, but that's not terribly creative. That's not why we're here. We're here to mess with this. Okay, so we can send any component to any other component. So for example, I can send luminance in this first column into the I component. Okay. And I can also maybe send luminance into the Q, but inverted. Now this is where we need to start thinking about our bias controls here, because luminance is unipolar, but I and Q are bipolar. So if we want to get, good results here, then we're going to need to play around with these bias controls. Maybe add some of that luminance back in. We can do that by just biasing everything up. That's going to just add a flat color. Or of course, we can add the original luminance back in. Okay, so that's more or less kind of what we were doing before with Proc when we were just using the luminance only. But of course, we've got these other components. So here's where things get really kind of weird and strange and unpredictable. If we send, for example, the I signal into the luminance, we'll need to bias this around in order to see it. So now we're actually looking at I as if it was luminance. Or we can look at Q by itself. And you'll notice that there's less detail in I and Q than there are in Y, and that is entirely by design. The Y signal carries all of the detail, and color is just kind of a sort of blurry wash. Okay, so now we're just going to see what kind of damage we can do. We can send I into luminance. We can send maybe negative Q into luminance and then play with the bias, right? Maybe we want a black and white. Maybe we want some kind of weird not solarization effect. This is a kind of strange look that we wouldn't be able to achieve really any other way. It's kind of sort of negative, but not, because it's based upon I and Q, not the luminance. We're mapping different chroma channels onto luminance. And of course, we still have the ability to add, luminance or chrominance to itself or to anything else. So now it's just, let's see what kind of crazy trouble we can get into, just by adjusting all the knobs. Turn all knobs, flip all switches, press all buttons, see what happens. Don't be afraid to do something crazy. I do it all the time. So there we go. That's insane. And great. It's insanely great. We've just mapped all of the color channels onto other color channels, in a completely new, different, bizarre, and, kind of unpredictable way. It's of course, it follows a logic, but it's not one that is really intuitive to me anyway. I don't know what result I'm going to get when I start playing with this, but I do know that it's something that I couldn't achieve any other way. There's only one way that this effect can occur, and that is by, mapping those YIQ channels onto one another. All right, well, I think that's a good place to stop, where we've kind of really, manipulated this beyond all recognition. So I hope you've enjoyed this video as much as I've enjoyed making it, and I just can't stress enough how Swatch opens a doorway into a whole new world. There's a bunch of stuff that I didn't even have time to cover in this, but I think that's enough to get you started on your path. Thanks a lot.